Hello. So in this video, we will talk about area and the ratio. So we have learned the methods of calculating areas of simple geometry figures in early studies. So in this section, we will investigate more on it. Before we start this section, you should be you should know a few things about area and ratio. We know that if two figures are similar, that means that the corresponding sides are proportional, and you are expected to know how to find the area of a rectangle, a triangle, a right angle triangle, and let's say parallelogram and trapezium. Okay. In addition to this, besides of applying formula of areas of figures, we should also have the following concepts. The areas of two triangles which have the same base and altitude are equal. So we are saying that if you're talking about two triangles and they have the same base and the same altitude, right, they are equal. Because to find the area of the rectangle triangle, we have two things here in the formula. That area, let's say you're talking about the first triangle's area, that's equal to 1/2 times, let's say base is A and height is H. And we're talking about the second triangle, maybe different shape, but it has the same base with the first triangle, and also they have the same height. Let's see here that these two triangles have the same area. So the ratio of the areas of two triangles which have the same base is equal to the ratio of their altitudes. So since it is we are talking about two triangles and they have the same area, right? And they have the same bases. So if you just take the ratio, right, 1/2, that common base will cancel each other. So it will be equal to the ratio of their altitudes. In a similar way, the ratio of the areas of two triangles which have the same altitude is equal to the ratio of their bases. Okay, so now let's just going to make use of these things in solving these problems. In this first example, E and F are the midpoints of A, B, and BC. Okay, as you look at this figure here, E and F, they are midpoints. So this side is equal to this side. And also BF, F is also midpoint of BC. So BF is equal to FC. Okay, so the area of parallelogram ABCD is 120 units squared. Let's say, what is the area of DEF? So we need to find the area of DEF. So the shaded region, we need to find this area. All right. So to do this one, so now let me just connect A with F and B and D. Okay. If you just make these connections here, let me draw this with, okay. If I just connect B with D and also A with F. Okay. So at the time, as you see here, first, if you draw a joint B and D, BD is the diagonal of a parallelogram. It bisects the area of the parallelogram. That means that area of ABD is equal to area of BDC. At the same time, since F is the midpoint, right? The area of BDF is equal to area of FDC. And also on the other hand, since let's say here, so the area of CDF, where is CDF? CDF. It is half of the area of BCD, right? And the BCD is actually half of the parallelogram. So the area of the parallelogram is 120, right? So this is 120, 120 over 4, that's equal to 30. So the area of CDF is equal to 30. At the same time, also the area of BFD, also that is equal to, what is it, 30. Now, also actually the area of ABF, we can see that also that area is equal to 30. Why is this so? Because if you look at these two triangles, triangle ABF and triangle DFC, right? And their heights are the same, and also bases BF and FC, they are equal. That means that their areas are equal. That means also the triangle ADE, ABF is equal to 30. On the other hand, also the triangle ADE and AEB, they are equal, and their sum is just half the area of the parallelogram, right, from here, and also the area of ADE is equal to 30. Hence, now if you want to find the area of DEF, what is it? That is the area of ABCD, the whole parallelogram, minus area of CDF, right? The CDF, minus the area of AED, and also remove this part EBF, right? Or BFA. So that gives us the area of EDF. So we know the area of the parallelogram that's equal to 120, CDF that's equal to 30, and AED that's equal to 30, and BFE that is the half of the triangle ABF, right? EBF, because E is a midpoint, that's why it's equal to 15. Now from here we get the area of DEF as 45 units square. So the area of DEF, the triangle DEF is 45 units squared. Okay. In the second example, let me delete this. Okay. All right. So, an example 2, EB divides rectangle ABCD into two parts. They are ABE and quadrilateral BCDE. The ratio of their areas is 3:7. Find AE to ED. Okay. And also here, let me just join first BD. Okay. So if we just join B and draw a diagonal of the rectangle, all right. So since BD is the diagonal of the triangle, actually it bisects the area of the rectangle. So it says that the ratio of the areas is 3:7, right? So that means, suppose that this area is then it is 3K. Okay, so the area of BEDC that's equal to 7K, right? And suppose that let's say this area is X. At the time, this area should be 7K minus X, right? So now first we can find the value of X in terms of K. So in our first step, since BD is a diagonal, right, the area of ABD, that is 3K plus X, that's equal to 7K minus X. Now from here, take X to the left-hand side. Here we have 2X, and 3K to the right-hand side, that's 7K minus 3K. Now from here, what is X? X is 7K minus 3K, that's 4K, 4K over 2, that's equal to 2K. So X in terms of K, X is 2K. In our second step, so now we're going to find the ratio of AEED, right? So the ratio AE to ED is equal to what? It is the ratio of area ABE, right, to area of EBD. And what is the area of ABE? That's equal to 3K. And the ratio of, the area of EBD, that's equal to X. What is our X? X is equal to 2K. So from here, this ratio is equal to 3:2. Okay. All right. Another example. Okay. Should again delete this. Okay. In this example, in the figure, ABCD is a trapezium. Given AD is parallel to BC, the area of ABE. So the area of ABE is 17. So let's write here, this area is equal to 17. Okay. So find the area of CDE. Okay, immediately we know that since AD is parallel to BC, the shortest distance from A to BC and from B to BC are equal. And also bases are equal. So from here, the area of ABC is equal to the area of BCD. Okay, so from here and after that, since they are equal, so the area of ABE plus area of BCE should be equal to the area of CDE and the area of BCE, right? So now, since I see here, BCE, BCE, they are common, right? From here, the area of ABE should be equal to the area of CDE. So hence the area of CDE is 17. Okay, or simply, since they are equal, also you can just solve it as, suppose that this area is equal to X, then this area should be 17 minus X, right? So from here, the area of ABC, that's equal to 17 plus X. The area of BCD, that's equal to just 17 minus X plus, what is it? The area of ABC, that's equal to 17 plus X. The area of BCD, it is, okay. Also, if this one is X, right, this should be, so 17 plus X, and also this should be actually 17, right, because that's a common part. Okay, so let's move to the next question. In question 4, in the figure, D is a point on BC. P is a point on AD, the area of ABP, triangle ABP, triangle BTP, and triangle CDB are 20, 12, and 50. Okay, so immediately let me just write those areas. The area of ABP, that's equal to 20. ABP, this area is equal to 20. And BDP, that's equal to 12. BDP, right, that's equal to 12. And the area of CDP, that's equal to 15. So this area is equal to 15. The question is, what is the area of ACP? Let's say that area is, it is X. All right. So again, from here, we are going to use that the ratio of the areas, right, is equal to the ratio of the corresponding sides if they share a common height. So from here, AP to PD, right, that's equal to 20 over 12. That's equal to 5 to 3. At the same time, the area of APC, that is X, to the area of PDC, X to 15, right? That's equal to also 5 to 3, because that's equal, actually these ratios are equal, right? Now from here, what is the area, the ratio? Since APC is equal to X, right? X over 15, that's equal to 5 over 3. From here, the area of APC is equal to 25, because 5 over 3 times, what is it? It is 5 over 3 times, it is 3 times 5, right? That's equal to 5. Or simply, since from here, right, APP, that's equal to 5 to 3, I can write here that is 5K, and this should be 3K. Now from here, 5K to 3K is equal to X over 50. Now from here, what is X? X equals 5 over 3 times 15. That's equal to 25. Okay, sometimes that using the names of the vertices, we can actually get the solution much faster. All right, another example, let's say an example 5. It says that we are given another problem. What is it here? We need to find the area of the shaded region. And what is given here? It's given that BD to DC. So BD to DC is, it is 2 to 1. So that means that if BD is 2x, right, DC is equal to x. Let me just write here, let's say it is 2x, this should be x. Okay, DC is x. E is the midpoint of AC. So that means that this is midpoint. So AE is equal to EC. And AD and BE intersect at P. Okay, this is an intersection point. The area of ABD, right? ABD, okay, that's equal to 30. Find the area of quadrilateral CEPD. Okay, so to do this one, first, actually, I'm going to, what is it? Divide this area PDCE into 2, okay, by drawing again a straight line, or even, okay, so with those, let's just divide this into 2 parts. Okay, so that's a straight line. All right, with annotation, let's draw nicely. So okay, So now we just divide the area PECD into two parts, right? Of course, they are not equal. Now from here first, since we know that the area of ABD is 15, right? Okay, so we can write this ratio. The area of ABP, as you see here, ABP, and the area to the area of BPD, right? The triangle BPD, that's equal to AP to PD, okay? And also at the same time, this ratio is equal to the area of APC, let's say APC, and the area of CDP. Why? Because their height from point C to the base AP or PD, they are the same, right? And that's why we can write this ratio. On the other hand, the ratio of triangle ABP, again, ABP to APC, right? So ABP to APC. You can see here, this one is APC. What is it? We have two triangles here, and that's equal to the area of BDP, that is BDP to DCP, it's area DCP, because also again, their heights are the same. And from here, we can have this relation that the ratio of the area of ABP to BCP is equal to AE to EC. Okay, and what is AE to EC? That means that they are equal, right? So that means that the area of ABP is equal to the area of BCP. Okay, they are equal. Anyway, suppose that the area of DCP, okay, DCP, let's say that's equal to X. Okay, let me just not, we'll see X here. Maybe I can write here 2K. Let's say this 2K and K. So the area of CPD or DCP, let's say that's equal to X. Okay, now we can just write here that BD to DC, that's equal to 2 to 1, right? And that means that the area of BDP must be 2x. So BDP, this area is equal to 2x. And how about the area of BCP? BCP is 2x plus x, that's equal to 3x. And also we know that AE is equal to EC because E is a midpoint. Then we can just write here then ABP, right? ABP is equal to BCP, that's equal to 3x. And the area of APC is equal to 1 over 2 times ABP. So it's half of the ABP, that's equal to 3 over 2x. And after that, the area of AEP, okay, the area of AEP, and also that's equal to area of EPC. EPC, that's equal to 1/2 of the area of ABP, right? ABP, because area of ABP, that's equal to the area of APC. So it's half of ABP, that's equal to 3 over 4, because APC is equal to 3 over 2x, and half of this one is equal to 3 over 4x. So now from here, we can write this equation ABC. What is ABC? ABC is equal to the area of ABP, right? ABP plus area of BCP plus the area of APC. And where's the area of ABP? That's equal to 3x. Area of BCP, that's equal to 3x. And APC, that's equal to 3 over 2x. And the area of the triangle is given, that's equal to 30. From here, if you solve this equation for x, we will get the value of x, that's equal to 4. Okay, so now we can get the area of the shaded region. So the shaded region, that is CEPD, is equal to DCP plus PEC or CEP. And the DCP, that's equal to x, and CEP, that's equal to 3 over 4x, and substitute 4x, and that's equal to 7. So the area of the shaded region is equal to 7 units squared. All right, so we have another example, example 6. Okay, let me just delete our deletion. Okay. In question 6, ABC is a right angle triangle, and AB is equal to 3. So this AB is equal to 3, and BC is equal to 4, and AC is equal to 5. Okay. Question 1A, find the length of altitude BE from B to AC. Okay, and since AC is given, it is 5, right? Now, what is the area of triangle ABC? The area of triangle ABC, just right here, that's equal to 1 over 2 times AB, that's equal to 3, times BC, that's equal to 4. On the other hand, since BE is perpendicular to the hypotenuse, right? And also I can just find the area by using this one, 1 over 2 times base, that is AC. AC is 5, and height, that is BE, right? So from this equation, 1 over 2, they cancel each other. What is BE? BE is equal to dot, dot, dot. BE is equal to 12 over 5 units. And question B, if P is a point inside triangle ABC, such that the distances from P to AB, BC, and AC are equal to D, find D. So that means that simply, what is it? If I join some, okay, here, since P is the point inside the triangle, right? We just join this one, okay, and here we have another triangle, and here we have another triangle, okay. So as see here, the area of APB and the area of APC, the area PBC, right? It just forms the triangle. So the actually, since distances, right, that is, this one is D, and this one is D, and this also D, and this also D. Yeah, simple, actually, these are the radius of an inscribed circle, right? So now from here, so number 2, what is it? The question is, we need to find D. So we know the area of the triangle, the area of ABC, that's equal to 1 over 2 times 3 times 4. That is the area of the triangle. So that is equal to 1 over 2 times the area of APB, that's equal to 3 times D. And the second triangle BPC, that's equal to 1 over 2 times 4 times D. In a similar way, the triangle APC, right, its area is equal to 1 over 2 times base is 5 and height is D. So just we can solve this equation to get the value of D. And see here on the right hand side, 1 over 2 is a common factor, and I can just divide both sides by 1 over 2. So this 1 over 2s, they are all gone. So now if you simplify the left hand side, that's equal to 12. On the right hand side, 3D plus 4D plus 5D, that's equal to 12. 12D, right? So that's equal to 3 plus 7. Okay, so from here, what is D? D is just 1 unit. That means that just we can draw a unit circle inside this triangle. Okay. All right, now we'll have the last example. After that, we will solve questions from the exercise. Okay, let me just clear the, yes. So in this example, given that AB is parallel to CD is parallel to EF. So these 3 lines are parallel to each other. Maybe I should use different color so we can actually see this much clearer. So this line is parallel to this line is parallel to this line. Okay. So the question here is prove that AC to CE, the ratio of AC to CE is equal to the ratio of BD to DF. Okay. Now, actually, these dashed lines were not drawn, but here in this picture, it's already added. Okay. So if you just add these dashed lines, if I join A with D and also connect C with B, and after that also E with D and also C with F. Okay. And also different way we can solve it, but here we're just going to follow the solution here. So from here, if you look at, what is it? ACD, right? ACD, right? ACD and also BCD. So ACD and BCD, what is it? They are equal, right? Why they are equal? Because their heights are the same, right? And also their bases are the same. Because if you're given any triangle, if you draw parallel lines, they just cut actually corresponding sides with equal ratios. That means that if AC is equal to, let's say, if AC is equal to A and also BD, it must be A. If CE is equal to, let's say, B, and also DF, it must be B. Okay. Now from here, because of similarity, actually. Anyway, so from here, we can just write here that the area of triangle ADC, that is A, let's say CD, is equal to the area of triangle, what is it, BCD. So BCD, okay. On the other hand, CD also is parallel to EF, right? I can just write here that CFE, right? CFE or CDE, CDE is equal to, what is it, CDF. So the area of CDF, or first CDE, triangle CDE is equal to the area of triangle, what is it, DCF, D triangle DCF. Okay. So now if you want to find AC to CE, then AC, just change the color here. Okay. So now we are going to show that AC to C is equal to BD to DF. So AC to CE, right? That is AC to CE. What is it? AC to CE is just equal to A over B, right? Or simply it's A to B. And also that's equal to BD to DF, right? There's the same thing, right? Because of these areas, A to B, right? What is A to B? Again, that's equal to just BD to DF. Okay, now we are going to practice a few questions from exercise 2. Okay, so let's start with this question. There are two rectangles. The area of the small rectangle is 30. The length of the bigger rectangle is 3 times the smaller rectangle. The width of the bigger rectangle is half of the smaller rectangle. Find the area of the big rectangle. So immediately we are talking about two different rectangles. So let's say this one is small one. Okay, so its area is 30. The area of the smaller rectangle is 30. The length of the bigger rectangle is 3 times of the smaller, and the width of the bigger rectangle is half of the smaller. So that means it is thinner rectangle, right? But it is longer. It is something like this. So let's say it's not drawn to scale. So we're talking about this rectangle. So let's say this width is W, then length is L, W is width is W. And how about the length of the bigger rectangle? That is 3L, and width is W over 2, right? The question is, what is the area of the bigger rectangle? Let's say it is A. Now from here, right, the area of the small rectangle, so the area 1 is equal to W times L, that's equal to 30. And from the second one, the area of the big one, let's say this one is a small one and this one is a big one. So that's equal to length times width. So that is 3 times length times width over 3, or width over 2. It's not 3, it's 2. So this is 2, right? Now from here, that's equal to 3 over 2 times length times width. That's equal to 30. 30 over 2 is 15. 3 times 15 is, it is 45. So the area of the big rectangle is 45 units squared. Another equation, second question, there is a parallelogram and a triangle. The length of their bases are equal. The altitude of the parallelogram is 3 times of the triangle. Find the ratio of their areas. Okay, now let me just do this without drawing anything. Okay, we are talking about two different shapes. Okay, let's say here we are talking about parallelogram. Okay, and this one is some kind of triangle. And it says that there's a parallelogram triangle. The lengths of their bases are equal. Let's say if the base is, let's say this A, and also base of the triangle is A. Okay, and the altitude of the parallelogram is 3 times of the rectangle. And let's say the height of the the corresponding height is h, then the corresponding height of the parallelogram is 3h. And find the ratio of the areas. And what are the areas of these two things? Actually, the area of the triangle is 1/2 times base times h. And how about the area of the parallelogram? It's just base times height. So that's equal to 3 times a times h, right? The question is, let's say this one is a1 and this one is a2. So we need to find their ratios. So here a1 to a2, right? That's equal to, what is a1? It's equal to 3ah over a2. That's equal to 1/2ah. So this a is the common factors, right? And 3 over 1/2, that's equal to 6 to 1. So the ratio of the areas is 6 to 1. All right, next question. In this figure, AD, I think we're given a square. Yes, ABCD is a square, and square is divided into two parts. ED divides square ABCD into two parts. BE to EC is 2 to 5. So that means that, let's say this one is 2K, and EC is equal to, what is it, 5K. And the area of CDE, right? The area of CDE is 120. So this area is equal to 120. Find the area of the trapezium ABED, because trapezium, because AD is parallel to this side, right? So we need to find this. Okay, so to do this one, again, I'm going to just draw a diagonal. Just change the color. Okay, blue. So from here, let me draw a diagonal of the square. And we know that the diagonal of the square bisects its area, divides into two equal areas, right? And from here first, let's say this area is equal to A. Okay. At the time, the area of ABB, right, it will be equal to 120 plus A. Okay, so here what we're going to find is we're going to find 120A plus 120 plus A plus A. So we need to find that area. Or even if I just denote the total area by A, anyway, that first let me just find the value of A. So as you see here, the ratio of this ABED, right? So the area of, let me just write here, the area of, what is it, triangle BDE, triangle BDE to area of triangle, what is it, EDC or CDE, CDE is equal to 2 to 5. So from, because they are sharing the same height, right? The shortest distance from D to BE and D to BEC, they are equal. So from here, the area BDE, that's equal to A, area of CDE, that's equal to 120, that's equal to 2 to 5. So from here, what is A? A is equal to 2 over 5 times 120, and 120 is divided by 5 is 24. 2 times 24 is 48. So now in step 2, we can find the area of ABED. Trapezium ABED is equal to 120 plus A plus A. So that's equal to 120 plus A plus A, that is 96. So this area is equal to 206 units squared. Okay, so dot, 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 the area of the trapezium is 260. All right, another example. Question 4. In this question, EF and GH divide rectangle ABCD into 4 smaller rectangles, as you see in the figure. ED is equal to 1/4 of AE. So ED, where is ED? ED is equal to 1/4 of ED. That means that if you multiply ED by 4, we get AE, right? So immediately, let's say if ED is equal to K, right? And ED to AE is equal 1 to 4. So AE is equal to 4K. And GB is equal to 1 over 3 times AB. So GB is equal to, let's say this one is K, or I can just write here M, right? So GB to AB, that's equal to 1 over 3. So AG should be equal to 2M. Okay, so that's equal to 2M. The question is, find the ratio of the areas of rectangle ABCD. Where's ABCD? ABCD, that's the biggest triangle, rectangle, right? To AGIE. So AGIE. Okay. So now simply, actually, since we know these ratios, right? What is the area of, let's say, the area of ABCD? Area of ABCD is equal to length times width, right? What is the length? Length is equal to 5K, and width is equal to 3M. So that's equal to 15KM. And how about the area of AGIE? The area of AGIE, right? AGIE is equal to AGIE against a rectangle, length times width. So that's equal to 4K times 2M. So that's equal to 8 times KM. Actually, this K times M, not kilometers. So now let me just label them by A1 and A2. Okay. So first step. Second step is we need to find the ratios. A1 to A2 is equal to 15 times K times M over 8 times K times M. So that's equal to 15 to 8. So the ratio of the biggest rectangle to the area of the rectangle AGIE is equal to dot, 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 that is 15 to 8. Okay. Question 5, given that AD is 1/4 of AB. So that means from here, 1/4 of AB, that means if AD is equal to, let's say, is equal to K, right? BD should be equal to, it is 3K, because the ratio of AD to AB, that's equal to K 1/4. And the ratio of the areas of BED to ABC, that's equal to 3 to K. So that means, I suppose that this area is 3A, right? So this remaining area should be, what is it? It is, since it's 3 to 7, it should be 4A. All right. So the question is, we need to find the ratio of BE to EC. Okay. So let's say, again, I really like actually using shortcut. Let's say this X to Y. The question is, we need to find X to Y. Okay. Now, first, let me just connect E with A. If you connect E with A, here we have E, and here we have A. Okay. If we connect this, at the time, as you see here, we are just dividing the area of ADEC into two parts. And suppose that, okay, suppose that this area is equal to capital X, or let me just write here, capital B. Okay, this area is B. This area is B. At the time, this area will be 4A minus B. Okay. So first, if you look at the triangle BED and DEA, right, the ratios. Number one, the ratio is 3A to B is equal to 3K to K. That is 3 to 1. Now from here, what is the area? 3 cancels each other, right? What is B? So from here, B is equal to A. Okay, 3A to B is equal to, okay, 3A to B, and that's equal to 3K to K. That's equal to 3 to 1. So 3 times B equals 3 times A. So B is equal to A. All right, so B is equal to A. That's the first step. So now we know this area, then this area is just equal to 3a. Okay, now as see here, I can again just write here the ratio of ABE, right? So let me just write here triangle ABE to the area of triangle AEC. AEC is equal to, what is it? X to Y, because they are sharing that common path. Now from here, let me just find X to Y. What is X to Y? The area of the triangle ABE. ABE is equal to 3A plus B. That's equal to 4A. And the area of AEC, that's equal to 4A minus B. So 4A minus A, that's equal to 3A. So this ratio is equal to 4 to 3. Right? So dot, dot, dot. The answer is 4 to 3. All right. Next question. In this question, given the area of trapezium ABCD is 234. Okay, ABCD, that's a trapezium AD is parallel to BC. Okay, so this side is parallel to this side. And ND is equal to 1/3 of AM. So if ND is equal to, let's say again, it is K, so AN should be equal to 3K. And MC is 1/4 of BC. So that means that if MC is equal to, let's say it is M, so BM, right, MC to BC, that's 1/4. So this part should be 3M. Okay. So now the question is, find the difference of the areas of ABMN, ABMN, and CDNN. MN. Okay, so let's say this area is equal to A, this area is equal to B. Here the question is, we need to find what is the difference, right? And now from the figure we can see that capital A is greater than B. So we're going to look, going to find this A minus B. Okay, so all right. Find a difference. The area of the trapezium is given, right? We know that from here, actually, what is given here? A plus B. That A plus B is given, that's equal to 234. This is given information. Okay, let me just not write. Let's say it's our first step. Okay, so, all right. Okay, first, let me find the area of A. Okay, so what is capital A? I'll say also ABMN is a trapezium, right? So that's equal to 1/2 times the sum of the parallel sides, that is 3K plus 3M times H. So now if I simplify this, that's equal to 3/2 times K plus M times H. On the other hand, how about the B, right? And also, as you see here, B is a trapezium because ND is parallel to MC, right? Trapezium means it's a spatial quadrilateral with a pair of parallel sides. So now again, using the area of the trapezium formula, 1/2 times the sum of the parallel sides, that is K plus M. And how about the height? It's the same, right? The shortest distance from AN to BM, right? It is the same. So 1/2 times K plus M, this is H. So now if we find the ratios, okay. Okay, we can find the ratios, how big they are, then I can find the value of A and B. So anyway, what is A to B or A over B? A over B is equal to 3/2 times K plus M times H over, here we have 1/2 times K plus M times H. So now these parts are the same, they cancel each other. 3/2 over 1/2, that's equal to 3. So from here, what is A? A is equal to 3 times B. Okay, so that is our first step. And the second step, I can find, what is it? The value of A and B. So we know that A plus B is equal to 234. If I substitute here, A plus, what is, okay, instead of A, what is, let me just write here, instead of, okay, here we have A plus B equals 234. A is equal to 3B plus B, right? So that's equal to 234. So from here, what is B? B is equal to 2, 3, 4 over 4. So that's equal to, divided by 2, is it 550, right? It's not divisible by 4. Anyway, 258. So that's equal to 58 points. And let me just write it as 58.5. Okay. So that's 200, 232, 58.5. Now from here, what is A then? A is equal to 234 minus, right, 58.5. So 234 minus 58.5, that's equal to 175.5. So now we can write this final answer here. Dot, dot, dot. We need to find the difference. A minus B is equal to, A is equal to 175.5 minus B is equal to 58.5. So that's equal to 107. So this actually, the difference is equal to 107.